So, hello everybody. In this lecture, we are going to see the pH metering. So, first is the principle of pH metering. So, pH value of solution expresses the degree of its acidity or alkalinity and is defined by the expression pH is equal to negative log of H plus ion. So, pH of solution is determined using a cell consisting of a glass and saturated calomel electrode. This is we have already seen glass and saturated calomel electrode. The arrangement also we have studied in the glass electrode. Okay, that we have studied before this lecture. So see here it is a glass electrode. Okay, and there is a test solution and there is a salt bridge, and to this side there is a saturated calomel electrode. So glass electrode and saturated calomel electrode are separated by a salt bridge, okay, and there is a test solution containing H plus ions. Okay, so determination of pH using combined glass electrode. Determination of pH using combined glass electrode. So the potentiometric method is a most accurate method to determine pH of solution. So for finding the pH of solution, an electrode reversible to H plus ion has to be used. Okay, has to be used as an indicator electrode. Has to be used as an indicator electrodes. What are the indicator electrodes? We know that hydrogen electrode or glass electrodes are used as a indicator electrode. Okay, so the glass electrode is the most commonly used indicator electrode. Glass electrode is the most commonly used indicator electrode combined with the saturated calomel electrode as a reference electrode. For your kind information, remember this saturated calomel electrode is a secondary reference electrode, and queen hydrogen electrode or glass electrodes are the indicator electrode. Okay, when glass electrode is dipped in a solution whose pH is to be determined, or that is test solution, potential is developed between the glass and the solution. The potential is developed between glass and the solution. The value of potential developed is a function of H plus ion concentration from the test solution. Okay, and that depends upon the nature of glass electrode. The potential difference is given by equation. See, the EMF of glass electrode is equal to standard EMF of glass electrode minus 0.05916 log of H plus ion. Okay, so what is this? Minus sign is there, log of H plus ion. We can change it to plus sign and we can write here as a pH. So EZ is equal to E naught Z plus 0.0591 pH. Okay, where EZ is the EMF of glass electrode, then E naught Z is a constant for a given glass electrode. The glass and saturated calomel electrode are dipped in the test solution and the EMF of the cell is determined using potentiometer. EMF is determined using potentiometer. The cell is represented by, see, this is what? Half cell. Okay, here, up to here. Okay, now this half cell is connected to this half cell with the help of this salt bridge. This is what? The glass electrode. To this side, this is a glass electrode. And to this side, this is a saturated calomel electrode as a reference electrode. And this is a indicator electrode. Okay. So now, and its EMF is given by equation E cell is equal to EZ minus E saturated calomel electrode. Now, as we know that EZ is equal to E naught Z plus 0.05916 pH. Okay, and EMF of saturated calomel electrode is 0.242 volt. So by putting values over here, we can find out the pH of solution, and that is given by equation pH is equal to E cell minus E naught G plus 0.242 upon 0.0591. Okay, by this equation we can find out the pH of solution. What is the instrumentation of pH meter? So the glass electrode has a high resistance and hence an electronic instrument called pH meter is generally used for determining the pH of solution. There are two types of pH meter. One is a potentiometer type, there is a direct reading. So in the potentiometric type, in this instrument, the glass electrode is incorporated in the potentiometric circuit, and off balance current are amplified electronically using milliammeter. Okay, using electronically, so that the milliammeter has to be used to detect the balance point. Okay, so here we are using the milliammeter to find out the equivalence point. Okay, and the whatever balance current is there, that was the amplified electronically. The electronic amplifier thus act as a null point indicator. So this amplifier acts as a null point indicator, or which indicates the equivalence point. Okay. So in the direct reading type, a linear relationship is established between the EMF of cell and the pH of solution. Okay. So that pH can be directly read on the analog or digital scale. Okay. Direct, that can be read on the screen directly. So this is how it is possible. Now applications in titrimetry or pH metric titration of strong acids versus strong base. So this is used over there. Now we know that as like a previous, we have to do the analysis, we have to add a titrant to the testing solution. And with the addition of titrant, we have to take large number of, we have to take the readings over there. Once we take the reading, so at the equivalence point, there will be the sudden change in the pH of solution. And that sudden change will give us a S-shaped curve, okay, that we call as a sigmoid curve. And from here, if you plot a straight line on the x-axis, where volume of titrant added is taken, so you will get the volume at the equivalence point. Okay. Similarly, one more graph is there, that is the delta P upon delta V versus volume of titrant added. So if you plot a line from this point on the x-axis, we will get the volume at the equivalence point. That is volume of titrant at the equivalence point. From this also, we can find out the pH of solution. Okay, one more graph is there, delta square pH upon delta V square versus volume of titrant added. So you have to connect just these 2 points, and the point of intersection on the x-axis will give you the volume of equivalence point. Okay, so it is necessary that from the all 3 graphs we must get the constant value of equivalence point. Okay, that is very important. Okay, so the all 3 graphs are there in the potentiometric titrations also there. Okay, all these 3 graphs are there in the potentiometric titration. Okay, on the y-axis, instead of here pH, we are taking their potential. Now, what are the applications? It is used to determine the pH of blood. As we know that in the nature, most of the processes, biological processes, happens at the particular pH only. So, in that biological process also, we need to monitor the pH or study the pH of the system. For that also, we are using the pH meter. Okay, so all type of acid-base titrations we are carrying out. For that, we determine the pH, and hence the pH meter is very important over there also. It is also used in the determination of dissociation constant of weak acid like acetic acid. Okay, and that can be accurately determined. It is also used in the monitoring the safe water or the pH condition of the water, or we can find out the pollutants present from the water. Okay, again, this is used in the estimation of metal ion from the water. Metal ion can be estimated in a minute quantity in the water by complexometric titration against, so EDTA, so detection of sodium using EDTA. Okay, at the constant pH, that is also possible. Okay, again, we can determine the pH of soil using pH meter, or soil acidity can also be studied by using a pH meter. Okay, so different enzymes which are complex proteins synthesized by the living organism catalyze the chemical reaction at a particular pH, and that pH can be studied with the help of pH meter. Okay, so after this lecture, there will be the last instrument from this unit, that is a conductometry. Okay, and after finishing the conductometry, your unit second will over. So for this lecture, I think pH meter is enough. So in the next lecture, I will continue with the conductometry. Thank you.